Hello everyone, welcome back. My name is Mr. Kovalt, and in this particular video, I'm going to be going over what the fundamental steps are of the scientific method. Before that, please remember to subscribe to my channel if this channel has helped you in any way, and if you like my videos, please help me to produce more and get paid for it. Um, so make sure you subscribe to the channel, share my videos, like my videos, um, and let's get into this. So, so the first thing that the scientific method starts with is observations, and it doesn't necessarily start with those. Although that is the most frequent starting point of scientific investigation. So, the scientific method starts with observations. We look around the world, we see what's going on, and we wonder why. What's going on? Why does that happen? Um, so that is the first part. We observe, we wonder about the world because of our observations. We see something and we say, well, why does that happen? And then we investigate. And so, first is observations. And then from our observations, we come up with a hypothesis. A hypothesis is a statement of what we think is going on, why we think this is happening. It's it's very particular to this particular observation that we're making. Um, and so when we come up with a hypothesis as to why we think this observation occurs, then we set up an experiment to test that hypothesis. And so we set up the experiment, we run the experiment, and then we gather more data, more observations from the experiment. And those new observations either confirm or disconfirm our hypothesis. So if it confirms our hypothesis, great. Then we go on and we make more observations. So the experiment will then allow us to raise more questions, ask more questions, see if the observation continues the more experiments we do. A great example of this is Antoine Lavoisier, who did so many experiments. He was focused on does matter stay the same during a chemical reaction? So if I have a certain number of or a certain amount of reactants, say I have 50 grams of reactants, will I end up with 50 grams of product in the end? And he did hundreds or thousands of these reactions. He burned a lot of stuff. He was very meticulous in his observations. He made sure he captured all the gases and got all of the products and tried not to lose any. And what he found was over and over and over again, he found that the amount of reactants that he started with equaled the amount of products he ended up with. So mass was conserved. So he did his experiment over and over again, making new observations, making another hypothesis, and experimenting. And so over time, we saw that this happened in different areas. Matter and mass are conserved in various areas. And so, what happens when we make these observations over and over again and they apply in the different areas, you'll see that this will then become a law. And a law is a general overall statement of what we tend to see going on in the world around us and applies to different areas. So Lavoisier was the person who was responsible for the law of conservation of mass. We see that mass is conserved across the board, and so we call it a law. Now, remember, the difference between a law and a theory is that the law is a statement that describes the overall observations of what we see happening in the world around us. It is not an explanation. It doesn't attempt to explain anything. It's more of the what rather than the why. What do we observe? that would be the law of conservation of mass. The theory is a general observation, I should say observation, a general statement of why these things are happening. It's trying to explain the law. So again, an example of a law, I'm sorry, example of a theory would be the atomic theory, that all matter is made up of atoms, right? And so we have a certain model. So model and theory go together. A model is kind of a pictorial, it doesn't have to be a pictorial, but it's a representation of what we think is going on. So we come up with a model of the atom in order to explain what's going on at the atomic level, to explain what's going on, what we observe regarding the law of, say, for example, the law of conservation of mass. So, um, the scientific method does not stop. We are constantly making observations, we're constantly asking questions, we're constantly doing experiments. There is no end to this process. It goes on and on and on, because when we come up with theories, these theories are not set in stone. These are constructs put together by scientists. They could be wrong, they can be changed, they can be adapted to new observations. And so that's what we see here. So when we come up with a theory, a general theory to explain what we're seeing in the universe, we can then make predictions and then test those predictions. So the theory of atomic mass says, well, if mass is conserved, then I should be able to see that in other types of reactions. Maybe I started off with just combustion reactions. So let's try other different reactions. I predict that that mass will be conserved in other types of reactions. So I run experiments for other reactions, and then I see if the theory is holds. Now, if my predictions do not come true, or if they're not supported by the experiment, then I need to modify my theory as needed. Maybe not the whole thing. Probably not the whole thing needs to be replaced, but maybe some part of it. Maybe it does need to be replaced with a new theory. Maybe there's other competing theories out there that would explain the new experimental data, so we might go to those theories. Or maybe the theory that I'm looking at needs to be tweaked a little bit. So I modify the theory, and then I start again with the new modified theory. Make new predictions and new experiments to support or see if those predictions come true. And so this goes on and on and on. So that, in a nutshell, is the scientific method. And again, it's a process that keeps going. It doesn't end, because we can never really know everything about the universe. We can never really know. There's always more to know, no matter how much you know right now, because we don't know everything, and so we're always learning. And that's what the scientific method is. It's a process by which we learn about the natural world around us. I hope this video is helpful. If you like this video, please like, share, subscribe to my channel, and give me any comments in the comment section that you think is helpful for me. If there's any videos you want me to do in the future, let me know. Thank you for joining me, and have a great day.